I'm Anil Kumar, and in this video we'll prove a trigonometric identity and review what we have learned about trigonometric ratios. So on the left side we have 1 over 1 minus secant x plus 1 over 1 plus secant x. On the right side we have minus 2 cotangent square x. We need to prove that left side is equal to right side. Let's begin with the left side. So we can take a common denominator of 1 minus secant x times 1 plus secant x. So when we take that as a common, we have to multiply the first term by 1 plus secant x. We get 1 plus secant x in the first term, and the second term by 1 minus secant x. So that is what you get after taking the common denominator. Now 1 plus secant x plus 1 minus secant x is 1 plus 1 is 2. So we get 2 over. Now here it is like a plus b times a minus b. So we get 1 minus secant square x. Right. So if you remember the Pythagorean trigonometric identities, one of them is, let's prove that one here, and I'll also provide you with the link of how to prove that identity. One of them is 1 plus tan square a is equals to secant square a, right? So from here, if we rearrange, what do we get? We get 1 minus secant square a equals to, I'm taking this, minus tan square a, right? So that is the identity which I'm going to use. It could be easily proven like this. If a, b, c are the sides of the triangle, and let's say this is angle a, then you know a square plus b square is equals to c square. Now to get this identity, we'll divide everything by a square. So a square by a square is 1. B over a is tan of a, right? So we get tan square a equals to c over a is secant square a. So that's a very simple proof which we have applied here. So what we get here is 2 over minus tan square x. Now 1 over tan, you know, is cotangent, so we get the right side, negative 2 cot square x, right? So some of you may not know this formula, that's why I derived it on the side. You can look into the link and do some practice questions. I hope that helps. Thank you.